All right, let's look at the homework 14.8, problem number 9. All right, so we want to use the Lagrange multipliers to find the shortest distance from the point 2, 0, -3 to the plane x plus y plus z equals 4. All right, so let's do that. All right, so since it's a distance, we can use the distance formula d, all right, is equal to square root of, right, so point is 2, 0, -3, so it's going to be 0 minus 2 squared plus y minus 0, so it's just going to be y squared. And then we have a z minus -3, so it's going to be plus 3 squared. All right, so since we don't want to deal with the square root, I'm going to go ahead and square both sides, so d squared, and we square this. Then this is equal to, of course, you get x minus 2 squared plus y squared plus z plus 3 squared. All right, so we're going to call this function f. So we want to minimize function f of x comma y comma z, which is exactly this. So quantity x minus 2 squared plus y squared plus quantity z plus 3 squared. All right, then subject to, so it's going to be, let's see, so subject to, all right, so this point has to be on this plane, so we have to satisfy, I'm going to call this guy g of x comma y comma z, which is simply x plus y plus z, and this is equal to 4. All right. All right, so let's do this. So we want to, let's see, set the gradient of f equals lambda times the gradient of g, right? So this will give us first partial of f with respect to x. So that will be 2 times quantity x minus 2. And this is equal to partial of g with respect to x. It's going to be 1. So it's going to be 1 times lambda. So it's going to be just lambda. All right. And the partial of f with respect to y would be 2y is equal to, and partial z with this g with respect to y would be 1, so it's going to be another lambda. All right, partial with respect to z would be 2 times quantity z plus 3, and this is equal to, all right, partial z, so it's 1 again, so it's going to be lambda. All right, so we got that. Then, of course, we have to satisfy this equality, so I'm going to just write that down. X plus y plus z is equal to 4. All right, since all these guys are all lambda, so we can probably just set them equal to each other. So I'm going to just say 2 times x minus 2 is equal to 2y. Which is equal to 2 times z plus 3, right? So I'm going to write y in terms of x and z in terms of x as well. All right, first thing is I'm going to just divide through by 2. All right, so we have that. So one thing is, so we can get here, y is equal to x minus 2. All right, and another thing we can get is z plus 3 is also x minus 2. So we can subtract 3 to get that z is equal to x minus 5. All right, so we know that we can write y in terms of x and z in terms of x. So I'm going to plug these guys. All right, so plug this guy in here. All right, and plug this guy in here. All right, so we're going to get, so this is going to be, all right, so you have x plus x minus 2 plus z is x minus 5. And this is going to be, well, let's see, there's 3 x's, and minus 7 is equal to 4. Right? So this is going to be, add 7. So 3x is equal to 11. So divide by 3. We get x to be 11 over 3. All right, so once we have x, we can find y too. So y is going to be equal to, all right, 11 over 3 minus 2. So 11 over 3 minus 2. 2 is 6 over 3. So 11 minus 6 is 5. So it's a 5/3. And also z is going to be x minus 5. So it's going to be 11 over 3 minus 5. 5 is 15 over 3. So this is going to be negative 15. So negative 4 over 3. All right, so we got the x value and y value and the z value. So we want to find f. All right. Well, actually, since we let's just go ahead and find the f. So here, f of x is 11 over 3, and y is 5 over 3, and z is negative 4 over 3. All right, this is going to give you, all right, so x is 11 over 3 minus 2, so it's a 5 over 3 squared, plus y is 5 over 3 squared. And let's see, z is negative, so it's negative 4/3, and you are adding 3, so it's going to be 9/3, so it's going to be another 5 over 3 squared. And since we're looking for distance d, is going to be square root of all this, right? So take the square root and take the square root of that. So that's going to be, we can pull out the 5 over 3. Then you have 3 of those, so it's a square root of 3. So which is going to be, just cancel them out. So you have a 5 over square root of 3. All right, so let's type this guy in. All right, so we got the distance. So this to be 5 over square root of 3. All right, so let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.